Hi, welcome to this development preview of ConnectFEA. So this is the new product we've been working on that generates geometry for steel connections, and we use the geometry and the setup through ConnectFEA to send it through to our volumetric finite element analysis product called SolidFEA. So SolidFEA will now become a part of ConnectFEA so that they work together. And we'll also link through to GenFEA, the General Finite Element Analysis software package. So what you see here on the screen is all of the 3D geometry generated in the model is generated from the input workbook on the left-hand side. So we've got profiles, plates, bolts, boxes for concrete elements, such as base plate connectors. Then non-structural elements, but still necessary, like planes. So we use planes to cut elements against those planes, and we can set up those cuts and connections between elements and how they work. Now, you can also create templates from your connections so that you can apply them easily in future connections. And then, of course, as you can see there, we're using the same section database that is connected to GenFEA. Now, currently you're seeing some of the modeling tools. So, of course, you can do things like copy, mirror, translate. You can also cut entities to each other. So if you wanted to cut, for example, that rafter coming into the base plate against the column, you can cut to that face. And there's a bunch of other tools that we can use to set up the analytical components. When we process the model, we're actually subtracting the bolts from the elements that it intersects with. So those bolts that is, drilling through the plate, and the flange of that column will be processed by the processing tool, and once that's done, we will run the automated hex mesh generator. So the hex mesh generator is fully automatic, which is quite a feat and an achievement in its own, and it does a pretty good job. It does take time, as hex meshing does, but it's fully automated, and we sped it up a little bit here. It took around about 10 minutes to run through this, which is still considerably fast. We then send this to SolidFEA. Like I mentioned, this is now packaged with ConnectFEA, so it's all connected. And as you can see there, it generates all of the information. So we've got the full model, full hex mesh model in here. It's already set up all of the materials, the sections, the element sets, node sets, surfaces, contact pairs. I didn't add supports in this model, but you can add it through SolidFEA. Very soon you'll be able to apply your supports and loads directly from ConnectFEA. And once you've run the analysis then in SolidFEA, once you've applied those analytical conditions, then this is the result that you're presented with. So we can switch off the contours for the elements that are not being investigated, so the column and the rafter, and then we can isolate the elements that we do want to look at, which is that end plate, the bolts, and the horch. So here we are seeing obviously much exaggerated view, but we are looking now currently at the von Mises stress, so we can see it's fairly low compared to the material strength, which is about 350 MPa, and then the Tresca stress is in there. We can simulate this, and again, this is exaggerated quite a bit. This is the deflection, but we can simulate it and see, how this mechanism performs and how it functions and what it does. The important bit here is that we're looking for a very good symmetry on both sides there, and again, we can see we're achieving that, and that's thanks to the high quality hex mesh that is being generated through the ConnectFEA tool. So that looks pretty good. We could further isolate this if we just wanted to look at the plate stresses on its own or any of those bolts individually. But as you can see, pretty good quality. So this tool will be available fairly soon. We expect in the next few months, hopefully by the end of the year, we'll have a fully functional beta ready. So keep watching and hope to hear your comments soon. Cheers. Bye.